Hello everyone, welcome back to this video on digital communication. In this video, I am going to talk about the analysis of the matched filter. So when I talk about the analysis of the matched filter, I must know two things about the matched filter. First, its transfer function or the impulse response, or second, the signal to noise ratio or the SNR value. So I need to know the two things for a specific input, and in this video I am going to analyze the matched filter with respect to a very popular input, which is Gaussian distribution. So I am taking the mean of the Gaussian distribution to be 0 to simplify the calculations. So the input is the Gaussian distribution with 0 mean. So I can write the input as xt is equal to 1 upon sigma under root 2 pi e raised to power minus t square upon 2 sigma square, because I took mean to be 0, so mu is 0. So t minus mean would be 0, so it is directly represented as t square. So now I need to find out the transfer function. So the first thing I need to find out the transfer function, and if I am taking the transfer function in the time domain, it would be impulse response. So now I'll be finding out impulse response. From the impulse response, I can easily derive out the transfer function. It's just the frequency representation of the impulse response. So I can convert the impulse response into transfer function with the help of Fourier transform. So now I am finding out the impulse response. So h of t was equal to 2k by n naught x of t minus t. So it's just the time shifted version of x when multiplied by 2k by n naught, I'll get the impulse response. So now this is why the impulse response is equal to the time shifted version of input signal. This is the reason it is called the matched filter. So ht would be equal to, so I'll just multiply 2k by n naught with this x value I am taking. Instead of t, I'll take t minus t. So 1 upon sigma under root 2 pi e raised to power minus, now instead of t, I'll write t minus t square upon 2 sigma square. So now this is my impulse response. So now I can cancel out this under root 2 as well. So it would be under root 2k So this is my impulse response. The first thing I already found out, which is impulse response for the given input, which is Gaussian in nature. So now I need to find out the second parameter, which is signal to noise ratio. So SNR is equal to 2e by n naught. So how it was equal to 2e by n naught? So E is the energy of the input, and n naught by 2 was the power spectral density of the noise. So input upon the noise, so it will give me the SNR value. So now I need to find out E, because n naught by 2 is a constant. So I need to find out E, and E is equal to minus infinity to infinity integration x square t dt. So now the value of x square t would be, first I need to find out x square t, so it would be 1 upon sigma square into 2 into pi e raised to power minus, now 2t square upon 2 sigma square would be equal to t square upon sigma square. So this is my x square t. So now I hope you understood how I cancelled out 2 and 2 here. So I need to find out energy, which is minus infinity to infinity 1 upon sigma square into 2 into pi e raised to power minus t square upon sigma square dt. So now this is a complex integration. So now what will I do? I'll take y square is equal to t square upon sigma square. So now, which implies y would be t upon sigma. And if I need to find out dy is equal to dt upon sigma, or I can say dt is equal to sigma dy. So I'll just replace these values here. So energy is equal to integration from minus infinity to infinity 1 upon sigma square into 2 into pi into e raised to power minus y square into dt. dt is sigma dy. So now this sigma would get cancelled out. So I am left out with, because this sigma and 2 and pi is constant, I can take it outside. Now I know the value of this integration. This value, the integration is equal to sigma under root sigma 2 into pi, and this integration is equal to under root of pi. So now E would be equal to, I found out E is equal to, I can cancel out this pi. So here I am left out with 2 into sigma into under root pi. So now I need to find out SNR. So SNR would be 2E upon N naught. So 2 into E, which would be 1 upon 2 sigma under root pi upon N naught. So I can cancel out 2. So it would be 1 upon sigma under root pi into N naught. So this is my signal to noise ratio for the given input, which is Gaussian distribution with zero mean. So now I hope you understood how I found out the signal to noise ratio and the impulse function. Now from this impulse function HT, I can find out HF. HF is the transfer function, so it's in the time domain. I can convert the time domain to the frequency domain with the help of Fourier transform. So now I hope you understood both of the things, and if you still have any doubt, you can put the doubt in the comment box and I'll try to resolve it. I hope you like this video. If you like it, push the like button and also subscribe to the channel. Thank you.